Hello, scholars. Okay, let's begin where we almost left off yesterday. So we're going to cover a few things today. I do not have the pencil that I used the other time, so it's going to look a little weird this time. But we have to cover rational numbers, making sure that you guys understand that what a set is, what a subset means, and what repeating numbers are. Those are easy. I'm pretty sure you understand that. And then the terminating numbers. Additive inverse, we really didn't cover it, so we're going to go over it today in the video. Okay, so moving on. We'll start with um, rational numbers. So rational numbers are basically any number that you can represent by having a whole number on the top and a whole number on the bottom. So rational numbers are numbers that are a ratio of two integers. So for example, 1 over 2 is a rational number because the number on top is a whole number and the number at the bottom is also a whole number. Um, the number on top, we call that the numerator, and the number at the bottom, we call the denominator. I'm pretty sure you remember that from your last grade level, but it's just a refresher. Again, in order for a number to be rational, you have to be able to convert that number in whatever form it may be into a fraction that has a whole number on top and a whole number at the bottom. So again, a rational number is a number that you can um, that is the ratio of two integers. It doesn't matter if they're positive or negative, as long as it's a whole number on top and a whole number at the bottom. No fractions, no decimal within the fraction. All right, so that is just for rational. Oh, this thing right here is for rational numbers. Let me get rid of that. Small. Moving on to what is a set? A set of numbers is basically the following. So a set of numbers would be, a good example would be here, from here to 8, let's say. From 0 to 8, that is a set of number. Just like when I said if you're buying a set of pencils or a set of markers, you're talking about um, a number of them. You need, it's not only one, it's two or more. So that's a set of numbers. Um, the whole thing from here to, let's say, -10, that is also a set of numbers. So we will call this, the purple part, a set of integers. And we call them integers because they're whole numbers. There are no fractions and no decimals. They're whole numbers and they're also negative. So you have all the whole numbers, which are positive, and you have the opposites of those, which are all the negatives right here. These are all the negatives. So those are integers. Integers do not include fractions and do not include decimals. That's for the integers. You cannot have any of those when you're talking about integers. Okay, so let me erase this madness again. So again, a set of numbers would be this whole number line. Um, this, this whole number line is a set of numbers. A subset of numbers is another set that is inside a set. So this is a subset of numbers. The long one is a set of numbers. Again, these right here from 0 to infinity on the positive side, that's what we call whole numbers. Whole numbers. Whole numbers. And all these numbers that you see right now, those are what we call integers. Integers. All right. So the next part that we're going to move on to will be repeating numbers and terminating numbers. The repeating numbers are the ones that whenever you divide them, For example, you have a ratio and you divide them, they just go on and on forever and they never stop. Um, we do that whenever we're dividing fractions, turn them into decimals. So let me give you a couple of fractions and then we'll go from there. So let's say that I have um, let's say that I have 7 over 9. That is a fraction. And if you remember yesterday's lesson, in order to turn that fraction into a decimal, we have to do a little something to that fraction. First of all, we have to turn it into a division. And then we get rid of it. And that number on top goes down to inside the division sign. So it'll go in here. 7 jumps inside, the 9 stays outside, and you erase it from here. So another thing that I told you that before you even begin to um, divide, you have to do something to that. You have to add a decimal, add a zero, and bring up the decimal. And now you have 9 going into 70 instead of into 7. Um, because 9 does not go into 7, we put a 0 on top. And now 9 will go into 70 about 7 times. 9 times 7 is 63. You subtract from that. So we cannot take away from 0. I mean, you can, but in this situation, we're just going to use it the way that you learned it last year. So you borrow from that one, this turns into 10, this turns into 6. So 10 minus 3 is 7. 6 minus 6 is 0. And now we're not done. We don't want any um, remainders. So we're going to add another 0 and bring it down, and you end up with 70 again. 9 times 7 will be 63. 7, you get 7, and 0 here, add another 0, bring it down, and you end up with 70 again. If you notice, it's a pattern. It just keeps going and going and going, and that never really stops. So we call that repeating. We say that 7 over 9 is equal to 0.7 repeating. That line on top means repeating. This line right here. Um, you could do it as 7, 7, 7, but because you're only repeating the first number repeats, that's where you put the line. So the line goes right here, and you don't need the other 7. So that's it. That's what we call a repeating number. A terminating number is different. That's the one that we did in class also. Um, if we have the following fraction, which is 3 over 4, and we turn it into a decimal, then we do that, bring the 3 inside, erase the other 3, because we don't need it, it already went inside. And now we can um, solve it. So first we had a decimal, a 0, and bring the decimal up right there. We always bring it directly on top of the other one. So 4 goes into 3 times 0 times into 3, and then 4 goes into 37. Um, well, 4 times 7 is 28. 4 times 8 is 32, so that's above 30, that wouldn't work. So we subtract here, I get 2, that is 0. Then you add another 0, bring it down. It turns that into a 20. 4 times 5 gives me 20, and that is 0. So 3 over 4 equals 75 hundredths. We call it hundreds because the last number is in the hundreds place. This is the tenth, that's the hundredth. So we would say that number as in 7,500. Because it doesn't keep going and going like the other one did, we call this a terminating number. Terminating number. So this one right here is terminating. All right. Now, so we covered whoops, what rational numbers are, what a set is, what a subset is, repeating numbers, terminating numbers. Now, additive inverse. For that, I'm going to use the number line. Additive inverse is the following. If I tell you to find the number 5, the number 5 is right here. And if I say, what is the additive inverse of number 5? Well, that will be the same number that is at the same distance from 0, but on the opposite direction. So it will be negative 5. That is what we call the additive inverse. Okay, so we're not going to really go into much of that yet. Just remember that whenever somebody says the additive inverse of a number is literally the same number on the opposite, with the opposite sign. So if I want the additive inverse of 7, that would be negative 7, because negative 7 is the same distance from 0 as positive 7, just on the opposite side. Okay, moving on. So we're gonna go to your book, to your resources. Eventually you will get this. There it is. Okay, it's making it bigger for you, so you can see it. Okay, so this is what you're supposed to figure out. See if that works. How do you turn 1/4 into a decimal? And then the ones over here, and what is that? How do you turn these right here into, it says right here. Okay, sorry. Um, so we're gonna work on this one right here. Basically, how do you turn um, this into a decimal? It says use a calculator, but remember that we're not going to use calculators in this course because you cannot use them in the ACP or the STAR. So it makes no sense for you to use a calculator. Um, so again, how do I turn 1/4 into a decimal? That's pretty easy, actually. Um, you already know how to do that. I taught you that yesterday. Was it 1/4? Yes, 1/4. 1/4 with the one inside. Erase the other one. And now you have 0. You have 10. So that goes, bring up the decimal. 4 times 2 is 8. 10 minus 8 gives me 2. That will be a 0. Add a 0, bring it down, and you get 20. 4 goes into 20 5 times. So 4 times 5 is 20, negative 0. So 1/4 equals 2,500. Let's plug that in and see if it works. 2,500. I wonder if you can later, you can do that. Okay. I don't know what this does. Um, Takes it away. Okay. The next one is 5/8. Let's try that one. 5/8 or 5/8. We're gonna do the same thing. The 5 goes away and it jumps inside. So we have 5. 8 cannot go into 5, so we put a 0. Remember that we have to put the decimal first, add a 0, bring the decimal up. 5 goes into 8 6 times. 5 times 6. Well, I mean, 8 times 5 is 40. 8 times 6 is 48. That is the closest thing that I'll find to 50. That doesn't go over 50. So that gives me 2, and that gives me 0. Add a 0, bring it down. Now I have 20. 8 times 2 is 15. That will give me 4. Give me 0. Add another 0, bring it down. And now I get 40. That goes exactly in there 5 times. So 8 times 40 equals 40. And now we get 625,000. And we call it thousands because it's in thousands place. So 625,000. And the next one will be for homework. So um, these right here. Oh, it should be able to write on here. I guess not. Okay. So going back to this, the homework for this part will be 2/3, 9, 2/9, and 12 fifths. Right here. 2/3, um, what is 5/9? Nope. 2/9, 2/9, and 12 fifths. You are to convert those into decimals and bring them to class. Um, Before I finish this video, I have to show you how to convert back into fraction. So for example, if we have the fraction right here, 0.2, this one's pretty easy. Um, so 0.2 or 2/10, we're going to turn it into a fraction in a very easy way. If we say it the way that it's supposed to be said using place value, we could call that number 2/10. Therefore, it will remind me that whenever I turn it into a fraction, it's just 2/10. That's it, 2/10. If it was 200, then I will put 2/100. The decimal goes away. And now I can reduce it. If you divide both sides by 2, you'll get, you will get 1/5. So 1/5 or 1/5 equals 2/10 or 0.2. Another one would be the following right here. Let's say we have 0.25 or 2500. Then to convert that into a fraction, all you have to do is put it over 100. And then we try to simplify. You always simplify as much as you can. The first thing that you want to do is see if you can divide both sides of the fraction, the numerator and the numerator, by the number on top. So if you can do that, then that'll make it a lot faster. I can't actually divide 100 by 25. That gives me 4. When you divide 25 by 25, that gives me 1. So the fraction version of 2500 is 1/4. I don't like this pen. It's not very good. Um, there we go. That equals 1/4. So basically, again, let me give you one more example, and then I'll give you an assignment so you can bring to class on Monday, Tuesday. So another example will be the following. We have 875,000, and I want you to convert that into a decimal and into a fraction. All you have to do is put it over 1,000 because we said that is 875,000. That is a little more complicated. Every time we have a 5 on top, and then if you have a 5 on top, and then you have a 0 at the bottom, that means you can divide both by 5 usually. So you can try to, what is it called? You can try to reduce it by 5, but that'll take you a long time. Go up to the next number. Um, can you reduce it by 25? And I think that's possible because 75 is divisible by 25. So let's see if we can divide both by 25. Divide both by 25, and you get, here you will get 40. Um, and you're probably wondering how do I do the other ones too much? If it's too much, we're gonna do it down here. I just need to make this a little smaller. 875 divided by 25. 25 goes into 875 3 times. That gives me 75. And then you get 2, and you get 1. Bring down to 5. 25 goes into 125 5 times. 25 times 5 is actually 125, so that gives me 0. So when you um, simplify that one by 25, you get 35 right here. And that number is still big, both of them, so we can still reduce. Now all you have to do is see if you can divide both by 5, and you can. 35 divided by 5 is 7. 40 divided by 5 is 8. So we can say that 875,000 equals 7 over 8. And that's it. Now let me see if I can give you a number that you can turn into a fraction. Let me find a good one. Let's convert this number into a fraction. I'll put it in green, right next to your other homework, right here. So your homework is the following. It's going to be those three right here, those three homework, and these two numbers that you need to convert into a fraction. 375 thousandths and 4.95. Turn those into a fraction. And a little clue, a little tip on this one right here, this number right here. If it's a whole number, you don't have to convert it into a fraction. You can just put it aside. So your fraction will be 4, and then whatever you get out of 95, that'll be next to it. It's called a mixed number. We'll go over those in class too. All right, if you have any questions, let me know. Sorry about the long video. I did a lot of talking, that's why. So I'll post this, and then you have until Tuesday to do it. Do not wait until Tuesday to get it done.